So I'll share the presentation and start. Okay. Let me know if you're able to see my presentation. Kriti, you're able to see the presentation?
Yes, it's up. You can start.
Thank you. Thanks one and all. Thanks for this opportunity, and it's a privilege to be with you today. And hope this 1 hour to 1 hour 15 minutes is useful for all of you in some form or the other. And it's useful for me also to refresh things. So first of all, thanks for the opportunity, Kriti, and thanks for the opportunity to the team. So I always like to start with this quote. This is one of my favorite quotes. And in fact, I would say not one of my the favorite quote. I almost start every presentation with this. Dream is not what you see in sleep. Dream is something which doesn't let you sleep. So I don't have to explain more. Speaks for itself. So this keeps me alive. This keeps me into. This is the whenever I am down. This is what keeps me up. And with the deepest gratitude, I would like to take this opportunity to make a difference. So give me your 60 minutes of your time, or whatever time you want to stay in the session. Let me see if I can make an impact to you or in your career. Having said that, thanks, and let me get started. And this is the theme, and this is an 8-week series which I am doing. Obviously, Kriti is as a series. They are adding other sessions too. But I personally am going to take 8 sessions, and this is in continuation of the last session that I took. That was a precursor, and this is the first session where we are going to talk how do you get qualified along with being certified. All of you are going to be certified. Most of you are in your college, or most of you are mentors, students who are going to get certified. Anyway, they will close the degree in some form or the other. Are they getting qualified is the question which needs to be addressed. So that's what the entire series is all about. And if you look at it, and I'm not saying certification is not important, but then to get a job, address certification. That's along with the entire series is all about. And you would have heard about a lot of people losing their jobs, losing jobs in IT and other things. But if you go and see, right, just look at the companies which are letting go people. If you look at it, they would let go 10%, 15%. I've not heard about a company which is letting go more than 15%, unless the company itself is closing down. But then you should look at why is that 85% of them are able to keep the job. Because they are needed for the job, they are qualified for the job. The 15% as somewhat for that company, for that skill set, they don't qualify. So that's it. So how do you get qualified, and how do you keep yourself qualified is going to be the theme, and it will define your life in not only in IT, in any career. So this is the theme: certification plus qualification. And actually the verses is not the you will need your certification, but then how qualified will require that to get a job and keep the job. So these are the 8 aspects which I'm going to cover. And today the focus is only going to be on technology. And because I am from IT, this will be more IT oriented this session. All the other sessions will be more applicable for every other stream. Even technology skills, about 50-60% you should be able to apply in your field, whether it is mechanical or electrical. But then it is more towards the IT, which I am coming. So I'm not going to explain these skills. I'm going to go directly. And in today's session, I'm seeing if I can complete it early and keep it open for questions. So let's see how it goes. So in terms of today's focus is vanilla technology skills. And if you look at out of the 8, right, this is the icebreaker, right? People won't see your other skills if you don't have this. That's the reality of life. You will have to clear your technology test, your technology interview, your technology coding interview. Only then they will look into other things. So this is an icebreaker. This thing for me, this will be your break. Other things are very important, but then once you clear this, other things will get important. If you don't clear this, the possibility is very low. Okay, so ensure that you focus on the area of technology, and this particular session is giving you insights into what you should focus on. Okay. this is your, and in terms of if you have your questions, you can keep noting it down, or you can keep posting it in the chat box, so that when the this thing comes up, I can take a question, or you keep noting it down when Kriti asks you to post it. You can either do one of those. Okay, and this is the fundamental slide, which we'll come back to the pivotal slide. If you look at it, right, from a technology concept, this is the 360-degree view of technology fundamentals. When I say fundamentals, your OOPS concepts, your object-oriented concepts, your logical thinking, your abstract thinking, your network knowledge, your computer knowledge, everything comes into technology fundamentals. And as part and parcel of your academics, I'm sure you would have learned subjects like that, but look at the practicality of it also. So that's the concept. So technology fundamentals, you, and I'll tell you, folks, the only, when I joined TCS 24 years back, they gave me about 6 to 8 months to get useful for the company. Today, we don't have that luxury. People who join the company need to be useful from day one, or not, if not day zero. Okay. So that's where this all this focuses upon center of excellences, or people training, or skill set training, and all. So ensure that the technology fundamentals are, and whatever you want to choose any type of career. Like I get to see engineers who come and ask me, I want to directly jump into cloud or AI/ML without knowing what technology is all about, what architecture is all about. You will fail, and you will lose job even if you get a job. Because what will happen is you will point blank. You get all your fundamentals right, only then you can go for this. Second one, coding is bread and butter for IT. Okay. So this is like I keep this stethoscope, right? A doctor will have to use a stethoscope anyway, and coding is your skill. Even if you are a manager, even if you are anybody in IT, you will need to know coding. You will have to have fundamentals of coding. Suddenly a code comes to you, you will need to review it, you will need to, and this is the beauty of IT, creating something. Coding helps you to create, right? So this is an important art. I would say coding is an art, and we go in depth in this session, where we will see the aspects of coding. Deep language, choose two to three languages. 2 languages is the minimum. Third language is a definite added thing. When I say language, Java or Python or whatever you want, everything has its own flavor. Today, Python and Java are one of the top. But if you want to choose that, whatever, you choose your language and get deep into it. You will need your language skills for you to. See, this is like this, right? People ask me, computers will replace, or machines will replace man, or AI will replace man. See, that everything has to be coded, and for that to be coded, you need to have deep skills. You will need people who will code those programs. You will need those AI/ML experts who will code it. Okay, so your language and your coding becomes very, very important. Full stack engineering, why I keep talking about this is your catch-all. Any point of time, if you want to know full stack engineering, there will be always opportunities for you. See, data might come down, cloud might come down, cloud might go up. Today it is cloud, today it is AI/ML, yesterday it was analytics, whatever. So, but if you're exposed to full stack, that will help you in your career. So I always, because full stack gives you an entire picture, front end, your back end, your server side, your DevOps, what happens in the end to end. So please spend that time to learn what is full stack engineering. And if you want to become a full stack engineer, that is well, and there is separate 50% of the jobs which come out in the market is full stack engineering. It's a huge number. 50% is a huge number. So, and even the billing rates from what a customer is willing to pay is about 40 to 50% more than a normal engineer. So please ensure that you understand, get exposed to full stack engineering. AI/ML, data and cloud, if you believe you have it in you, learn that knowledge based and also practical based. This is one line which I want to leave away from you. Multiple lines I leave, but one of the critical lines. In future, coding is your only resume. The code that you have written is your only resume. So you have to start coding. If you are a first year, second year, third year, fourth year, what I don't care who you are, you have to show code. That's when, see, your the entire interviews are now based on coding. And if you want, if you come and show the code that you have written, and don't cut and paste code and make it your code. Your code, if you show to people, people will look at you. Technologists want to see code. So that's the thing. You all have to have GitHub created and start putting your code. Whatever you write, an hello world program, put it there. You write a tool, put it there. But slowly increase your level of concepts. So that's from my technology skills. Quick check, Kriti, you're able to, I'm audible, right? Kriti or Naveen?
Yes, Dr. Ashwin.
Yes, we can.
And then this is specifically into a coding is an art, and this is what I want to cover to you in terms of these 7 concepts of code. How do you learn? How do you develop coding as an art for yourself? Okay, and this is from one of the I have shared the link also. I found it very useful because it exactly captured my thought processes also. See, language, as I told you, 1 or 2 languages, Java or Python or any .NET, deep skill set. It's not superficial skills. When you say I'm a Java, you have to be minimum 7 on 10 or 8 on 10, more than that. That's called knowledge. You can't say I'm 1 on 10, 2 on 10. You have to be 7 on 10. So language and learning today is easier. You have so many course materials. You can join courses, but join courses which are based on coding. Don't go for only theory, because I'm assuming theory you will have covered in college. You can learn yourself also. Learn the coding from code. Whatever you want to do, get the coding aspect of language along with the concepts. Okay, so minimum when you get to a final year interview, if you do not know 2 languages, it's by luck you will get a job. It's not by your skill. So ensure that, and I'm being very blunt here. To know 2-3 languages, the probability increases by more than 50%. And when you say no, you have to be minimum 7 on 10. That's the level of knowledge that you need. And if you know 2 languages, and if you go into an interview, if you don't get a job, they come there for not. They don't have a job for you. That's all. Because this is the top skill. We need the coders, and language is the best form of showing your code skills. Coming into logical, and I will not going to stop here in terms of coding. I have a couple of more slides on coding and what exactly that you have to focus. I'm not going to say this is an in-depth session. Logical thinking. So what is logical thinking? Logical thinking is just breaking up a big problem statements into smaller units and see how they interact. So that's logical thinking. So when a problem statement is given to you, say opening a bank account is given to you, what all you think about, what are the different processes, how do you break it, so what all can fail in it, what all can be successful in it. So that's logical thinking. So account opening, so what, it should be a 10-digit number. If it is a 10-digit number, why should it be a 10-digit? Why can't it be a 2-digit number? Because the company has a plan to grow into multiple numbers. So it's logical thinking. So you need to think about breaking the problem statement into smaller blocks and combining that. So that's logical thinking. So this is an important skill. You can't learn the skill, you have to develop the skill. Logical thinking is developed by taking some problem statement, splitting it up, creating code out of it. That's the only way you can develop logical thinking. And it's breaking up a problem statement. It's breaking up a problem statement. That's where you have all these analytics and all the tests that we keep, right? How can you break a problem? How can you apply whatever you learned there into smaller blocks and interconnect them? That's logical thinking. Very important to do your coding aspect. Detail oriented. See, it's about not coding is all about, or IT is all about detail oriented. See, the customer comes and tells you, I want a remote monitoring of my employees. The employees are all working offline. The employees all working offline. I want to monitor their work. If this is the problem statement, and if you are writing software for it, what all details you will get in terms of okay, the person is there. What is the working time? What are the times he can take a call? He can code. He can attend meetings. He can attend seminar, or he can chair a meeting, or he can just attend a meeting. And in terms of, he can also mentor his team. He can architect for a solution. He can code for a solution. So there are multiple. So you have to get into the details. It's not about superficially working out. Software engineering is all about getting into details. So if I give my team, and I have some of my best team members. So when I give them a problem statement, even if it is an operational problem statement, people have to work from, say, during this COVID, right? The COVID situation, we all had to work. Everybody had to work from home. And the first 2 3 weeks, the problem statement was, how do we make it work, and how do we make all the enabled systems work? It's about details. So what is the detail? What is be required? If there is a quick software solution that is required, or if there is a product that is there, can we take and tweak it and put it? These are details oriented. So in software engineering, where people fail is superficially understanding the requirements, and that's puts off the computer, puts off the. For example, if you are developing a retail solution, you have to ask about the tax. You have to ask about the invoice patterns. So how is the details you are capturing? That's very important. Understand computing, very important. See, there used to be a garbage in, garbage out. Computers are like, initially were dumb machines. Now with AI, they are also learning. But then bottom line is all about bits and bytes, right? So you have to understand what is computing all about. How you can speak the language of a computer with your code, from a logical, how you logically analyze it, break it into a problem, put it into a language which the computer understands, and understand the computing powers. What is it there? So in terms of, and these are, you can share, I will share this presentation also. You can go to this specific site, or you can understand. These are all on the net. You can really read about it. Spend that time into understand what is computing all about. What can computers in the current, because when I started my career, what computer can do now, that point of time, and what computers can do now has changed. So this is all about not one time reading. This is not one time you have learned and one time you're keeping. It is for then ever. No, it has to. You have to keep learning. Thinking. The second one is thinking about abstract thinking. And this is a very important concept. How can you create, how can you abstract things? For example, if you're talking about, say, I talked about opening up an account, right? So what are the elements there? The elements is a bank, an account, an employee, a customer, Ashwin, if you want to say Ashwin is a customer, and he interacts with the computer. It's all in the physical world, but how do you abstractly think from a code? You have a person, for example, he interacts, he can, overall he can interact with the bank. He can interact on the web, he can interact on an ATM, he can interact on with the agent. So how do you abstractly start thinking as elements and how interaction? It's a very important, see, this logical thinking and abstract thinking and understanding computer. Please spend some, it's very difficult for anybody to take a class on it. It's about you spending that energy and spending that, and that's where, if you look at it, you can think why people, companies who come for campus interviews give those logical tests, right? It's all because you can't be taught logical thinking. You can't be taught abstract thinking. How well you break? We see these characters in college. They might not spend understanding the subjects, but they can be great logical thinkers. You have to develop that skill. The next is scientific method. Think about, software is not by chance. For example, a product like Microsoft presentation doesn't get created by chance. It's done with a scientific method. When I say, there is requirements gathering, there is testing, there is validation, there is version control, there is product management, there is performance management, PPT, people will, how all it can be used, whether it can run on a Mac, whether it can run on a Windows. So there is a scientific method to this madness. There is a process. So it's not about somebody asks you in your lab, right? When I used to be a fresher, I used to get an write a program to sort. We go immediately write and sort, right? Real-time world problems are not that. I won't say that simple is a very wrong word. It's not. It's actually more complicated or more real-time. For example, this COVID is a real-time solution, right? You can see Google and all creating products to, for example, the COVID the platform to see where all people are affected by COVID, or where all you can get help for this thing, or during the flood, what is the recover mechanism? These are all scientific methods of looking at things. It's a process, it's a procedure. Understand it's a process and the procedure. Only then you'll be able to develop something which is valuable to the company and the customer. Last one is very interesting, self-reliance. I can see this habit of some asks you to code, search for the code, cut and paste and put it there. That's the worst thing that can you do to yourself first. Forget the company. Because what happens is you will never learn the art of coding. See, it is not that everything you have to develop, but everything, if you start cutting and pasting, what happens is there is no individuality and you don't learn. And if you don't learn, you can't contribute your ideas. And the important aspects of taking in freshers into the team is, right, people come in with thoughts which we don't think about, which the customers also not think about. I have had in my previous companies when I used to be a module lead, I used to work with freshers. We used to come ask questions which are thought provoking. They will ask a question in terms of which will change the entire program, which is a 100-member team. They will change it because and that's what we need. We need people who are thinking. So that's really important of getting self-reliant. So these are the 7 aspects of as when you want to develop coding as an art, and that's what is needed for the career. It's not something which is don't think when I say as an art is a nice to have. This is a must have, and this is the must have. All these 7 are must have, and that's what will define you to get a job and also to stick onto the job. This is all that. And why does good code matter? In terms of good code, see what happens is when you write a code, it is not one time. Okay, what happens is when you write, for example, this present, say this Microsoft PPT code is written, you will integrate new features. So tomorrow something happens, a presentation has to integrate with say an Excel or some other different tool. You will have to integrate, and that time you have to code. So it's not code once written will never be touched. So when you want to integrate it, you have to be, there has to be good code for people to integrate. So that's where, so when, for example, look at it, right? If once code is not touched for about say 6-7 months, it means it is not required. Because that's the world is changing. The world is changing. You cannot think about everything. So that's where integrating new features and your code being able to integratable word I will use. I don't know whether it's for part of English, but then this integratable code is very important. And then what happens is many a time, many people have forgotten what a lot of code does, because it's just cut and paste from somewhere. They don't require certain code lines. Maybe that doesn't get executed itself. That happens, and it's like this, right? And girls, in terms of when you write code and somebody else takes the code and writes, the feeling that they get is a very important aspect of you, because the impression that you leave. And the third one is time spending in fixing of code, the bug fixes and all that stuff, right? So it's all about cost and also about energy and also about and these are sometimes you write code which are, imagine I write code for an account, I transfer it to X and it goes to Y. And imagine a little bit more, medical equipment, what all it does. Imagine now you're writing an automated car and there is a bug. And if it is an automated car, what it can do. So this is about time and issues that fixing old code can create. Kriti, you're able to hear me, right? I'm hearing some noise back.
Yes.
Okay, great. So this is the 3 aspects of good code. And if you have time, we will go into each of the subjects. But then this is the 3, and this is also taken from a website. I've given this website. Good code is all about three things, folks, if you want to summarize it. And this is also called abstract thinking, right? Syntax, how well you can write code, how is the code represented, how is the code aligned, how is the code able some people to understand syntactically, how is the architecture of code, for the oops concepts are implemented, how the interface concepts are implemented, how the repository is done, how the data architecture is analyzed. So this is the second one, is the architecture. Third one is the workflow. When you say workflow, what is the version control? So people all to understand there are different environments. When you write code in labs, it's just you code and show it to your supervisor. It's not like that in the software world, right? You write code in the development environment, it goes into the quality environment, then it goes into the pre-production environment, then it goes to a performance testing environment, and then it goes to production, the final life. So what is the workflow? How do you understand how this now it's all automated? How do you understand the workflow process of it? So in terms, and when I say all is automated, this is the problem, right? We all think all is automated, so we don't have to know about it. It's not the case. Many things will fail, and people who really are the stars in the project know how that can be fixed. So these three aspects of code, when I say good code, so you want to, as a fresher or even as a faculty, if you want to teach your students, this is the three aspects of it. And this is a way very well of abstracting it syntactically, architecturally, and workflow wise. How is my code placed? How do I rate my code in these three aspects? That's called in the ingredients of good code. And these are concepts which I took from a site because I wanted to represent. I also was thinking, how do I say what is good code? These are things which we practice and we expect. But I think this site captured it very beautifully. I thank two of my team members who actually gave this site to me. It actually captured and represented this. I just put the diagram. The points were actually good, very well represented. So this is from an ingredients of a good code. Then getting into, actually I have two important slides, and actually each one of the syntax, architecture, workflow, I have a separate slide, but let's see how the time and then get into it. But before I wanted two slides for you to all take home with respect to whether you are a faculty or you are a student, and some of my team members are also there. Tech roadmap to have a fulfilling career, and this I think is has come out very well in this entire presentation from as I said. I will sometimes you have to comment, applaud yourself also. So if you look at it, right, if you want to get into the IT field, your fundamentals, algorithms, logical thinking, abstract thinking, good coding practices, this is very important. Second, language, Python, Java +1, whatever you want to do. Scripting languages, JavaScript, AngularJS, whatever you want to choose. Then it comes to architecture, patterns, use case, interfaces. Then get into full stack exposure. And then get into your expertise in your selected field, whatever you want to be. Full stack engineer, AML, DevOps. I just put listed top 4. You can. There are many more also. The most important thing is the last one. Don't think there is a start to this. There is never an end. So this is a key takeaway. There is a start to this. There is a never an end. Learning journey continues. In fact, nowadays, our appraisal cycle itself, we have a learnability as a parameter to gauge people. And it's very much a fact. We learn what is the time they spent on their training, what is the output they show, what is the interest levels they show on training, what is the self-trainings that they have done. Very important in terms of you understand this roadmap. And I think this is a very beautiful thing which you can internalize it, maybe in the colleges, what you can want to do in terms of how you want to structure your preparing a guy or a girl for this thing, for a campus. If you have these concepts in some form or the other, fundamentals, language, scripting language, architecture, full stack exposure, expertise in your selected field. And when I say expertise, it's about getting trained, showing code, getting some real-time exam, working experience. Even when I say internship is a very beautiful model. How do you get all these? Will have a fulfilling career. And most important, if you want to stick on to this career, you have to keep learning. You have to keep learning. in whatever way you want to do. And so this is a very important slide. Actually, it should come to the end of the presentation, but I didn't want to, lack of time, I didn't want to miss this slide. So I just wanted to cover this slide. Take roadmap to a fulfilling career. Any questions I can take during the Q&A session. Text two important things which, as I told you, coding will be your resume, and your resume in future or even today has to have these 6 concepts. Your GitHub repository with the code that you have developed, what all code you have developed, and how you have progressed code. Projects that you have done, simple projects to complicated projects, to simple your college you have done, or to your friend's company you have done, or to or for your hobby you have done. What are the projects that you have done? What is the methodology? What is the architecture that you have used? Can you explain your project? It's also about your college project. What do you have in mind? It's very important. And it's not about college project writing 2-3 lines about it. It's real-time experience. And if you're doing an internship, what you have done in the company internship. Expertise in 2 to 3 languages, it's a must-have. I can't speak more. Scripting and full stack exposure, this has to be on your resume. Area of interest and time spent. If you're saying I want to be a data scientist, or if you want to say I want to be a AAML, what have you done to become an AAML? Have you learned the maths? For maths is a very important concept of AAML. Without maths, nothing can be done in AAML. What is the time that you have spent? What is the language concept that do you know Python very well to become an AAML? You know the tools which are used. Have you done something? So it's not about I am interested in this, right? That's not the resume. That's not the resume. You can talk that also. What your resume should contain is what is the time spent, and even if you're a 3rd year, final year, time is not lost. Join something, or you yourself spend time and get this all. The last one is process, tools, oops, expertise, knowledge, and actual implementation. However, you've done small things in your projects, in your sample projects, in your college projects, in your internship projects, what have you done? If you ask me, these 2 slides, tech roadmap and your resume, is a must-have and a must-key element for anybody who's coming into looking for a job in IT. Okay, and if you want to expand it to other aspects of mechanical, electrical, you can do. In fact, I was thinking I should work with a couple of my friends who are in that field to develop this. But if you look at this is a roadmap for a fulfilling career in IT and what your resume should contain. Okay, so this is 2 important concepts which I will want to leave with you. Let me took 11:05. So Kriti, till what time you want to go ahead and open for questions? Another 10 minutes?
Yes, Dr. Ashwin.
Okay. So, I will come back if there are some questions to this. Tech roadmap and your resume. Okay, and let me cover it one more time from a resume concept. Your code, your projects, your expertise in 2 to 3 languages, scripting and full stack exposure, your area of interest and time spent, and your architecture and process knowledge must be in your resume. Apart from your other personal aspects, what you want to be, what you want to do, those are comes in the second page. The first page should be this, and all should be captured. And even if you're a fresher, this is expected. This is the 3 parts I told you: syntax, architecture, and workflow. I won't cover a lot, but if you look at this is what the good code is all about. How do I name a variable? I read this somewhere. Naming a variable is like naming a child. Naming a file is like naming you. How well you can name. And this is Martin Fowler himself. Any fool can write code that a computer can understand. Good programmers write code that humans can understand. So this is Martin Fowler for you. It's not from me. So Martin Fowler is one of those fathers of computers, from coding. So ensure that anybody can write code that a computer can understand, figuratively understand, use this. But good programmers write code that humans also can understand. As I told you, because code has to be maintained, code has to be done a lot of things. So this is, I'm not going to go. You can go to that site which I told you. There's a beautiful. Avoid writing comments, because what it means is your code should be so well written that it is a comment for itself. You don't need separate comments. So this is how well your code is written. And formatting is very. When I see a code which is not formatted, or it's very awkward. That's the right word. Then what is a good architecture? What is the use case? What is not a use case? What are the data? What are the interfaces? What are the repository? What are the tools? In your project, you should be able to tell all this and this is also part of that site which I gave you. Please go into that and see what are the different principles that you have used in your architecture. In terms of workflow, what is the version control? What is the continuous integration tools? What are the code analyzers that you have used? What are the testing processes that you have used? People nowadays do. A lot of manual testing is moved into automation testing. How can you test your code? Even the simple code that you write, how can you demonstrate that you have written automation script also to test it? So these are things which you can impress upon an interviewer who comes to your to your college and ask you, I've written this code and I've also written an automation script that will test this. Or if I'm writing a product suite, I've also written, and don't copy this. And it can be 2-3 people together also. Me and my friends have written an automation script which will test by itself. So these are the things, and what is the version control that we use? These are ingredients of a good code. Last couple of slides. These are the top languages which are there: Java, Python, scripting, C++. These are the top coding, and this is from Coding Dojo. Look at, I'm saying Java and Python, if you know, it's more than enough. But scripting, apart from scripting. But if you want to have exposure in C++, C#, go ahead. I think this is my last slide. So these are the top 5 key takeaways from my session. I always like to summarize. 2 languages in depth, understand the aspect of what good code is, internalize the concepts of art of coding, roadmap for tech learning, which I gave you that roadmap, understand how architecture needs to be applied, understand the process of software building. The last but not the least, concentrate on the must-haves which I showed you. These 2 slides which I showed you, very important and represented for you to understand. Ensure that you spend some time and reflect on this. It's not about immediately going and writing your resume with these. Reflect. Okay, out of this 6, how much I have? Maybe I have 4 on 6, and 2 I have to develop. Let me develop and put it in my resume. Or I don't have anything, then you are in red zone. So let me start developing. Nothing is right. Last but not the least, let me tell you one law. I don't know how many of you have seen this. Parkinson law of time. Time expands. If you have 1 month, you can get prepared. If you have 6 months, you can get prepared. So you can go and Google it, Parkinson law of time. So time expands in the sense, I've seen it in my managers, and hopefully my managers are not in this call. What you can do it in 1 week, maybe if you put time and energy and concentration, you can finish in a day. So focused on it, and don't have to rush it. But then when you have focus, what I'm saying is, when you are not focused, suppose there's a project for 1 year, many of the 1-year projects fails, that's what agile is all about, right? If you go and search on Google, you'll say projects with our 1 month, 2 month duration are more successful than projects with 1 year duration. And if you look at it, even if you see dams which are built, right? Look at the dams which are built for, if it's more than 5 years, then you're done. The dam is definitely not going to be built, because it won't have the latest and greatest technology used. It will be old. But if it is done on a proper 1.5 years, 2 years, 3 years time, it's more used. Okay, so this is the Google it. It's a good principle, Parkinson law of time expansion. So this is, I think I almost covered 5 takeaways, and thanks. Wishing you most and more in this journey of getting qualified. And as I told you, this is an 8 series session. I've completed the first introduction last 2-3 weeks back. Today I'm doing the first. I will do 7 more sessions on management skills, communication. Maybe where you will have a session where we will sum it up also. Okay, that's it from my side, Kriti, and thanks for the time. And I will open up for questions.
Thanks, Dr. Ashwin. So we have quite a lot of questions ready. So I'll read them one by one.
Yeah.
So the first question is from Bharat. Bharat. He wants to know, while writing a code in DBMS, how can we be sure about the logic for authentication, as everyday new cybersecurity issues are coming?
See, specifically, I do not want to get into DBMS part. See, this security is a real-time thing, right? So what happens is, there are always patches which come up, and you have to implement them. For example, it's like when security is not one time. So let me give you an example. Every day when I log into my